A Van der Graaff generator is a device that is used to build up very high voltages of a few million volts. This high voltage can build very strong electric fields, which can accelerate charged particles to very high speeds and high energy levels. Generally, this apparatus is required when conducting experiments involving the study of subatomic particles. To understand the principle behind the working of a Van der Graaff generator, let us consider a large conducting shell of radius r1 with a charge plus q1 on it. This charge is uniformly spread over the conducting shell. For such a charged conducting shell, we know that the electric field strength inside the shell is 0. And the electric potential V inside the spherical shell has the same value at all points inside the shell, and V is equal to 1 by 4 pi epsilon naught Q1 by R1. Let this be equation 1. We also know that the electric potential at the surface of the spherical shell is equal to the potential inside the shell. Let us assume that there is another smaller concentric sphere of radius r2 with a charge q2 on it. Now let us consider the potentials at the surfaces of the inner and the outer spheres. Let the potential at any point A on the surface of the inner sphere be VR2. This potential is due to the charge on both the spheres. Then VR2 is equal to 1 by 4 pi epsilon naught Q1 by R1 plus 1 by 4 pi epsilon naught Q2 by R2. Here, 1 by 4 pi epsilon naught Q1 by R1 is the potential due to the charge on the outer sphere. And 1 by 4 pi epsilon naught Q2 by R2 is the potential due to the charge on the inner sphere. The potential at any point B on the surface of the outer sphere is VR1. This potential is due to the charge on both the outer sphere as well as the charge on the inner sphere. Hence, V of R1 is equal to 1 by 4 pi epsilon naught Q1 by R1 plus 1 by 4 pi epsilon naught Q2 by R1. Here, 1 by 4 pi epsilon naught Q1 by R1 is the potential due to the charge on the outer sphere. And 1 by 4 pi epsilon naught Q2 by R1 is the potential due to the charge on the inner sphere. The potential difference between the inner and outer spheres is delta V equal to VR2 minus VR1. Substituting the values of VR2 and VR1 in the expression for delta V and simplifying, we get delta V is equal to 1 by 4 pi epsilon naught Q2 into 1 by R2 minus 1 by R1. We see that the potential difference delta V depends on value of Q2. Since Q2 is positive, the value of delta V is also positive. This clearly implies that the potential at the inner sphere is greater than the potential at the outer sphere. From the expression for delta V, we also see that the potential difference between the inner and outer spheres is independent of the charge Q1 given to the outer sphere. If we now connect the inner sphere to the outer sphere, charge flows from the inner sphere to the outer sphere, since the inner sphere is at a greater potential as compared to the outer sphere. Therefore, We can keep on adding charge to the outer sphere by supplying charge to the inner sphere as it flows from the inner sphere to the outer sphere. Therefore, the potential at the outer sphere keeps on rising until it reaches the breakdown field strength of air when it starts leaking off to the air. Due to the small charged sphere, which is within the large sphere, we can keep piling up larger and larger amount of charge on the latter. This is the principle of the Van der Graaff generator. The schematic diagram of the Van der Graaff generator is as shown. It consists of a hollow metallic conductor A, which is mounted on an insulating column. A pulley B is mounted at the center of the sphere A. Another pulley C is mounted near the base of the conductor, and C can be continuously driven by an electric motor or by hand in case of the device being used for demonstration. A belt of insulating material such as silk or rubber passes over the pulleys. As the pulleys move continuously, the belt also moves continuously. Two comb-shaped conductors, X and Y, having metallic needles, are mounted near each of the pulleys pointing towards the belt. The lower comb X is maintained at positive potential of about 10 power 4 volt by a power supply system. The upper comb Y is connected to the metallic sphere A. Because of the high electric field near the needles of the comb X, there is corona discharge, and the air near it starts conducting. The negative charges in the air move towards the positively charged needles because of attraction. The positive charges in the air move towards the belt due to repulsion and stick to the belt. The negative charges neutralize some of the positive charges on the comb X. The power supply keeps supplying more positive charge to the comb X, and effectively, the positive charge is transferred from the power supply to the belt. As the belt moves, this positive charge on the belt is carried up, and when it reaches near the upper comb Y, corona discharge occurs again, and the air starts conducting. The negative charges in the air moves towards the belt, and the positive charges in the air move towards the needles of the comb Y. The negative charges neutralize the positive charges on the belt. The positive charges in the air, which have moved to the comb, are effectively transferred to the sphere A. Effectively, the positive charge on the belt is transferred to the sphere, and in a very short duration of time, the positive charge on the sphere moves to the outer surface and spreads uniformly. Thus, the device continuously transfers positive charge to the sphere A, and hence, its potential keeps on increasing. The potential builds up till the corresponding electric field reaches close to the breakdown field of air, which is of the order of 3 × 10⁶ volt per meter. The limiting factor on the value of the potential of the sphere is the radius of the sphere. When the electric field outside the sphere A is just sufficient for dielectric breakdown of surrounding air, no more charge can be transferred to the sphere A. A sphere of radius r equal to 1 meter can be raised to a potential of 3 × 10⁶ volt by this method. The potential can be further increased by placing the sphere in a highly evacuated chamber, in which case there will not be any air surrounding the sphere.